Hey guys, it's Klinger with Vital MX. Today we are with Robert Reisinger from 6D. We're at 6D headquarters, their helmet headquarters, and we're going to talk a little bit about kind of helmets in general, but there's a lot of technology right now that's coming out in helmets. In 2012, you guys started, introduce your helmet,
Correct.
and it's pretty much was kind of kickstarted the industry paying attention to rotational energy management. And so just to start off, why don't we have a brief kind of overview for those that are maybe new to the sport, they haven't seen it before, a brief overview of what the omnidirectional suspension system is that you guys use and how it differs from kind of the typical moto helmet.
When 6D started its efforts, Bob and I were working on the concept of how to address rotational energy mitigation during an impact event. Mm-hmm. And that ended up moving us into a direction of a dual liner system. What we're trying to do is generate a system that allows the head and the outer impact energy of the shell to move at different rates from each other. Mm-hmm. And when you have just a solid monolithic, single piece EPS liner in a helmet, your head's coupled to that at some point as you smash and rotate into that. And that material itself can't shear and move, but when you're in a crash event, your helmet's hitting the ground and your head's still inside moving. Right. And the idea is to let it slow down and change directions at a different rate than what the impact's trying to drive it to. And that lowers the overall amount of kinetic energy that's transferred from that impact event into your brain.
As a consumer, as someone that's, okay, I saved up a good chunk of money, I want to buy a helmet, how are we kind of supposed to digest this information, or at least what is 6D's view of all these different systems out there?
One is you're going to have technology like 6D's ODS, which is really the area that most people don't try and play into, is where we have an inside liner. We also have an outside liner, and we separate the two liners with an air gap that we can control motion around. Mm-hmm. And then most of the other technologies, MIPS primarily works on the area of having the technology. MIPS has two technologies, but most of the MIPS you'll see will be a sliding liner that will be inside the comfort liner that helps the liner and the head slip around on the inside. So you have technology that's inside the helmet against your head, and then you have technology that's inside the helmet itself and not against your head. Okay. So that's the basis of the two technologies, having your head move inside where it's already moving, right, but adding to that, or having a technology where the helmet's trying to move around itself, like the ODS system.
As far as introducing rotational energy management, what can the test do, or is there a move towards, what are we seeing as far as like standards to test these things?
When we started back in 2011 with the concept and trying to play with it, we were reading medical journals and looking at what they were saying helmets aren't doing to protect the brain in areas that we need to look at for protecting the brain at different levels of energy transfer. Right. And while most helmets in the last, at least in the last 8 years, have been growing in size a little bit, we're only talking 6 millimeters here or there in the surface, but 6 millimeters is enough to get an energy management improvement in various areas, especially on the sides of the helmets where energy-wise we'd like to make them a little rounder, but style-wise most people won't like that style until it becomes a standard that we have to perform equally in all areas on the helmet. And the outside shell in a motorcycle helmet is primarily there for hard point loading. So when we talk motocross, we got foot pegs, we got axle bolts, we've got all kinds of things that can get us, especially if you're crashing in a motocross race, in the first lap and the first couple of turns. There's a lot of things around you that can that clock you and hit you if you're on the ground. For example, when we were developing the ATR2, because the internal components of it, part of them are multi-impact and part of them aren't. Mm-hmm. And we did that for a purpose. We wanted part of it that was going to be part of the helmet to be multi-impact so we could tolerate more. We didn't have to gut the entire helmet. In our ATR1, 6D developed a rebuild process early on in the introduction of our helmet because we saw people going out there and crashing early on after buying an expensive helmet. We knew it's expensive, and we said, well, how can we help them bring the cost down? And that was, well, can we rebuild these? Can we replace the guts? Because we'd see helmets come back that were intact. The shells look good, but the guts have been smashed inside. And we came up with a way to do that. Well, the ATR2 was designed from the ground up to be a rebuildable helmet. And rebuilding a helmet that's not, it takes a lot of work. So we had a lot of labor into rebuilding the ATR-1s, and we still do that today. The ATR-2, we distilled it down to pulling 2 bolts on the chin bar and bringing out the chin bar assembly, pulling 4 snap pins that hold the inner liner in, and pulling it out of the ODS system and replacing it. And the inner liner against your head is EPS. So it's the expanded polystyrene, the styrofoam ice chests are made out of. And that's a crushable liner, and EPS is a very good energy absorption material.
You know, there's data, there's numbers that you get in the test lab, and then there's kind of real world application.
So many variables get involved with what spin forces put on the helmet. So it gets hard to repeat it. You have to standardize and sanitize your methodologies really well, you know, and so you have to really break it down into small pieces.
So, I mean, some other companies kind of talk about they want to get their helmet, like the overall even shell size, as small as possible, and light as possible. And that argument from, you know, coming from them is that the smaller it is, the less leverage there is, and the lighter it is, the less momentum there is.
A helmet gets bigger, and yes, it can pull more. And when you talk about pulling, well, that's a function that's defining issues about your neck. And while that has merit to it, most helmets are only growing by small amounts, 6, 8 millimeters, 10 millimeters. It's not much. So when you do the math of it, empirically the math will tell you that the moment arm is bigger and you have more force to pull on something. Right. So that's true. But when we break it down and we talk about accelerations, it's just the opposite. Right. So when we talk in accelerations, these notions of smaller radiuses are going to help our brain. From physics perspective, that's wrong. Right. Because the smaller it is, the faster the inner objects will spin to the impact event. The larger it is, the bigger radius on the outside says I have to travel a longer distance to move the same amount of rotation.
Looking into the future, I mean, you have the ATR-2, and then what's next?
Well, we're constantly working on evolutions to our technology. Okay. Every year we learn something new about the methods that we can use to attenuate energy. Our technologies will continue to advance. The ATR-2 is our most advanced technology used today. We're working on ways to try and manufacture the technology in lower cost methods so we can bring the price down on helmets. That's the big negative of putting a lot of engineering time and having different component parts into a helmet. Right. Is that the cost goes up in manufacturing. So our technologies will move towards trying to improve cost, right. But we'll continue to try to increase the amount of energy that we can manage. Today, we're managing great energies compared to just 5, 6, 7 years ago.
So can you tell us a little bit about what the NFL Head Health Challenge 3, what that was and how you guys dealt with it?
Yeah, sure. The NFL had a calling out to industry at large, people across the world, to enter these contests that they were putting together to examine all ideas and all methods to manage different types of energy. So they established these tests or these contests. One was the Head Health Challenge 1, the 2, and the 3, and we entered into the Head Health Challenge 3 contest, okay. Which was about creating energy management mitigating systems, so they could actually learn more and see what kind of technologies could come up. So the NFL had an open application, and they received a little over 125, I can't remember the number, applicants for the Head Health Challenge 3. They selected 20 of those companies to then develop a proposal and an initial prototype to send in to them, and out of that 20, they distilled that down to 5 organizations. 6D was selected out of the total applicants to be the 5 participants in this contest and the challenge that they had. And the challenge was to follow their protocol to build energy management technology systems and submit them to them for their testing. And we had a year-long program that we had to document everything we were doing, why we were doing it, and what the intent was, explain it to them, and then give them a test sample. At that time, we introduced what today now is a big piece of is the ATR-2. And over the course of the year, we had to submit certain samples at certain times and reports at certain times, and they would test them and then get back to us with the data. And at the end of the year, they were going to pick the winner, who could show the best mastery of managing and manipulating the technology to perform in a certain way, and whose systems performed over their testing protocols for the best energy management in linear and rotation. Okay. And 6D was picked as the winner for the Head Health Challenge 3. So we were instrumental in helping, going through some of that, and now we're actually in the process of also working on a football helmet for an undisclosed client right now. And if everything works out, we should see a football helmet in the coming year with ODS technology in it.
Wow, that's a pretty big deal.
Yeah, we're excited about it.
Yeah. Well, thanks, Robert. We touched on, I think, everything that we wanted to talk about. And if you guys like this video, hit subscribe. And thanks for watching.